Welcome to the Prosys OPC ProveIt live session. In this session, I will first introduce our company and us, and then explain shortly our approach to combine OPC UA and UNS. Then we will go to the live demo or the ProveIt demo, and finally we will check the conclusions and the questions like how we did it and why we did it and what did it cost and so on. But let's begin from our company. So Prosys OPC is a 30 years old company. We are specialized in OPC UA, IT/OT integration and industrial security. Our customer base is very global, so we have more than 1,000 customers in more than 50 countries. Here at ProveIt, our team is me, Pyry Grönholm. I am CEO of the company. My colleague Jouni Aro is our CTO and is later showing us the actual ProveIt live demo. And we also have Iivo Yrjölä from our support and customer integration team here with us to give us necessary support when we struggle with Jouni. But let's go to the topic of combining OPC UA and UNS, which is, might be a little bit controversial for some people. So, what's OPC UA? It's a standard. That's good to understand. The standardization body of OPC UA is OPC Foundation. It defines communication protocols for different levels. So it's not just only one protocol, but like set of protocols under the OPC UA umbrella. The benefits of the OPC UA is that there is cross-vendor compatibility due to the standardization. It has security inbuilt and very large adoption in the OT companies. The main protocol within the OPC UA is the client server, which we recommend everyone to use on the OT level. The real benefits of the OPC UA client server is that it's a request response. So the client and the server, they know about each other, they know whether the other party is alive, and they know whether the other party received the data that they were trying to either send or write. This is very important in the critical environments, like OT setups. It also defines standardized payload and address space, so basically like the OPC UA servers and clients, when they connect to each other, it's plug and play, and you don't need to do any manual configuration to make it work. Then if you look at the UNS, so it's a concept, idea, that we would have all the company data in one single place, structured logically, typically using the ISI 95 format. It also kind of enables easy integration. MQTT, which is typically used in the UNS, is an easy protocol, easy to take in use, very much supported by all IT systems as well as the OT systems. The challenges with the UNS is that there is no exact actual standard for the topic tree nor the payload. So when you build your UNS, you never end up in a situation where it would be really like a plug and play, because you always need to do manual work to check what is the payload, what is the topics. Worst case, the same topic can receive different payloads from two different places, and you need to create some kind of customized logic to understand and kind of decompile the data. Our approach is to combine these two technologies. So we believe that the best UNS is built in a way that you have one aggregating OPC UA server on your site, which is built using standard models like the CESMII Smart Manufacturing Profiles and using like standard and ISI 95 structure. Then you just publish this OPC UA address space to MQTT broker using the address space as the topic tree structure. Also, you can define your own standard payload. So every single variable is sent to MQTT using the same payload. When you then leverage this from one site to all of your sites, you will have a complete UNS using standardized topic tree and standardized payload. Okay, that's now I have explained our approach to do the UNS. So I will hand it over to our CTO, Jouni Aro, which is actually explaining our ProveIt demo.
Okay, thank you, Pyry. So let's go on through the Prosys Forge first. That is the application that we use to implement the demo. Forge is an application that combines the industrial DataOps, and it can run as an edge application. It has OPC UA server as the core, so we bring in all the data into an OPC UA server. We have variety of southbound connectors that we can use to bring the data in from different PLCs, from MQTT, from files, databases, and so on. And then we can take it out through high-level systems such as MES, analytics, AI, and so on, to cloud using different northbound connectors such as MQTT, or we can use OPC UA because we have an OPC UA server there. That's natural for several applications. But we can also use the REST API that is built into Forge. It's actually providing data, but we can also do all the whole configuration through the REST API. The idea within Forge, the original idea is that we can add more advanced OPC UA functionality so that the manufacturer can start using OPC UA not only for communication, but on the information and semantic level as well. This is the high promise that OPC UA has always given, and it's the most exciting part of OPC UA actually, that you can have a standard language to model all kinds of domain-specific topics in manufacturing, not vendor-specific, but vendor-independent. Forge runs in Windows, Linux, or in a Docker container environment, and is therefore deployable however you need it. It has a web configurator, very modern design and architecture, and it's actually based on our long-term development of OPC UA SDK for Java, which we have had in the market for 15 years. And this is a strong basis for building this end-user application that can put together all our knowledge, all our expertise in how OPC UA can be used for the best purposes. Information model transformations is a big topic, but it's still something that is basically lacking because it's not a simple topic. And the other obstacle has been that the products in the market are using OPC UA only for the communication. They don't let you use the information modeling as much as would be possible. There are already some products and some PLCs that enable this, but overall, there's a lot of legacy OPC UA servers that are basically just enabling you tag-based information. Now, Forge is here to enable these transformations. And the idea behind the information models is to standardize. Like in this picture, you see we can have like robots that are all having their own information model. They are vendor specific. They all maybe have the same features, but they still look all very different. Now, within Forge, we can bring in a standard robot model and reform the data from the legacy models, and then make them all look the same, follow the standard robot model. And then this information can be made available to higher-level applications like MES, SCADA, dashboards, analytics, and AI, for example. Now, these are the tools that we use for this ProveIt challenge. What did we do in the ProveIt 26 challenge? Well, it's comprised of 4 parts. We have first a southbound connection, so we bring in data from MQTT, OPC UA, databases, and FTP servers. Then we contextualize or harmonize this data using CESMII OEE models. And in Enterprise B, we also use a custom ISA 95 model that we built ourselves. And in Enterprise C option, we use the OPC Foundation process automation device information model. On the third part, we publish everything back to the UNS broker as MQTT messages, and then we can also visualize that in Grafana dashboards. As extras, we can add history to data. We can use redundant features, meaning we have been logging data from one of these OPC UA servers in case we lose a connection, which seemed to happen during building up the demos. By logging data, we can then play it back with our simulation server and replace the online connection to the actual virtual factory. We can replace that with a simulation server connection. And we can also implement an OPC UA publisher, which is a more standard way to publish to an MQTT broker. Now the Forge solution here is using all these different data sources. We are harmonizing within Forge, and we are providing the data to MQTT, OPC UA applications, and REST applications. So in Enterprise A, if we look at that more specifically, we are subscribing to the MQTT broker because the data was only in an MQTT format. And we found out that there is custom OEE data for this enterprise. We mapped that to the standard CESMII OEE profile, meaning we had to rename tags that are available from the MQTT broker, and we had to scale them to percentage. We published that to the MQTT broker using our UNS publisher. And as extra, we provide dashboards in Grafana. And we can also provide some documents to the OPC UA clients. Here are more details about the transformation. So the MQTT topics that are available are called availability, performance, quality, good count, and bad count. But we noticed that the CESMII profile actually requires also a sum of, or the overall OEE as a percentage. So we had to calculate that ourselves. So that information was not available originally. On the other hand, we noticed that the total count that the CESMII profile requires is not available, so we can calculate that. And now this standard information model can be made available. And let's see if I can show you how that is configured in practice. So here is the Forge user interface. I'll take the mouse as well. So first of all, this is how the Forge configuration looks like. So it's a web interface. We have the OPC UA server address space visible here as the main user interface. We can add different data sources. And now we see that we have lost the connection. How come? It's a demo. So we lost the connection to the Enterprise B and Enterprise C. And on the other hand, we have for the Enterprise A, we have an MQTT subscription, and that is available over here. We have a connection to the Enterprise A. That's still alive. And we have a subscription where we defined which MQTT topics we are listening, and we are taking those to the respective OPC UA topics. We have here a redundancy model built in for these factories, which should now convert the data coming in from the redundant server, which is here we can see that it's configured to come from the simulation server instead of the actual server if the connection breaks. So let's see if that really works now. So we go back to the original OPC UA server. We will find the Enterprise A not from the data sources because it's an MQTT subscription, but we have now modeled the Enterprise A OEE measurements under the line 1 using the CESMII model. How did we do that? I can show you that I can create a new OEE measurement here. So with Forge, it's very easy to add new nodes in here. And I'll show you that we brought in the CESMII Smart Manufacturing Profile for OEE as within an OPC UA node set file. And for Enterprise B, we also defined some additional ISA 95 structures. We had to modify the CESMII model a little bit, so they are now combined in one node set. But here we see that from this node set file, we bring in the CESMII OEE model in. And once that's in, I can create the node, and I can choose the CESMII profile, and then I have the alternative to select the respective types that can be used. So the CESMII profile defines 4 different types. There's an OEE summary interface type, availability interface type, performance interface type, and quality interface type. Let's just pick the summary interface type, and we'll now call this OEE summary. And we save the node, and now we have a new node that looks the same as the original summary that we had already built in here. So this is how we standardize. And as you remember from the picture here, we had to calculate the OEE. So here we have a mapping which defines how we calculating the total OEE from the availability, performance, and quality, which were as percentage, and we still have to ensure that this is in percentages. So let's move on to the Enterprise B. In Enterprise B, we have now identified that there is an OPC UA server where we can bring in the data. There's a custom ISA 95 hierarchy, and then there's also OEE data. There was also a connection to the work orders available from an SQL server, And now we're mapping this data. Again, we took the custom ISA 95 hierarchy model. We defined our own ISA 95 types for areas, work centers, and so on. And we map the custom data to our own standard. But we also use the CESMII OEE profile to map data to the standard. Now it's in a different format, but we map it again to the same format, similar as we did in Enterprise A. And we again publish it to the UNS processor. I will show next to you how that happens as well. And then we have the Grafana dashboards that put these things together. So let's look at the Enterprise B. So now the Enterprise B data is available here, how it's defined originally. We can find that there are these sites. They have different areas, process areas, and each one of them have the OEE measurements as metrics here. But again, we see that there is just the measurements, but this doesn't look like the CESMII model. So we go to our own Enterprise B. First of all, we've defined our own types here. I can show it from the OPC UA server better how it looks like. But let's look at the OEE measurements first. So here we have the same OEE model. We have the percentage, we have the availability and performance and quality. And all of these are now mapped using the Forge mapping capabilities. So this just shows that it's coming from the original OEE tag, from the original OPC UA server. And we also had to scale in this case by 100. So here is actually what we had to do here. We had originally in the OPC UA model, we had OEE availability, performance, quality, and we map it to the CESMII standard model. We can also look at the server with our Prosys OPC UA browser. So this is how the OPC UA applications see this data. And in Enterprise B, we now have sites, and you can see that this is actually of ProveIt site type. So this follows our own model for ISA 95. There's a filler production, which is an area. There's a filling line, which is a filling line. There's a cap loader, cap loader that is of a cap loader type, and so on. And the OEE measurements here are of our own ProveIt CESMII OEE type. And then we have the summary is following the CESMII type. And I can double click here and I can see that this is actually the CESMII type here where it comes from. And then let's go back to to Forge. Now we are publishing both of these enterprise data to the ProveIt broker. So we have publishers here for the ProveIt broker for each enterprise. And these are actually so-called UNS publishers. So we basically just defining one root node under which we want to publish everything to the broker. And the same configuration is done for Enterprise B. And now if we find the MQTT Explorer here, okay, let's make a connection. And let's see what we have here. So this is just filtering now what we are publishing over there. We find the OEE measurements in here. And also the same for Enterprise B. Let's pick the filler production, for example. The OEE here is following the same structure. If you look closely, you notice that the payload of the messages is still different. That's something that we can configure in Forge. If we want to have only the value, or if we want to also include the timestamp, you can define all of that yourself. This is one of the things that MQTT or UNS doesn't define what is the payload of the messages. So we need to be flexible to provide any alternative. There's also an option to publish with the OPC UA publisher. OPC UA PubSub defines more standard formats, but it's also a little bit flexible so that you can match it with your actual requirements. And then we have the Grafana dashboards that we built. Now here we can show the OEE data the same way for Enterprise B and Enterprise A for all the sites. And now it's easy basically to build the dashboards because the data is harmonized. It's always the same. The people don't need to understand where is the availability, how is it called, where do I find it. It's always in the same format. It's always in percentages and so on. That's the whole idea of harmonizing data from different data sources. And that's what we can do with OPC UA and with different information models. And CESMII Smart Manufacturing Profiles are in fact just OPC UA models. Okay, since I have still some time, I can also quickly show how the Enterprise C was modeled. So here we have a little bit different process. This was actually a really process automation factory, whereas the other ones were more discrete manufacturing. In discrete manufacturing, you can use OEE, but in process automation, you don't really do that. Here we found that there was an OPC UA server, but all the data was just available on a flat tag list. We could also get some information from FTP server and make that available. But the main idea here that we figured was that we can use the OPC Foundation's process automation device information model and remap the tag-based information to a more hierarchical model. The PA-DIM is rather extensive. It's building on already other OPC UA models, such as the device information model, and just extending that. What is standardized is how you represent the tags for the different devices, machines, how you use integer units, how can you define set points. And it matches very well with the process of the Enterprise C, where we have control valves and pumps and other equipment like that. Again, we can just publish then whatever we've made available to UNS publisher. We can have a Grafana dashboard. We can add history data and so on, and make that redundant with the OPC UA server. So let's see a little bit what we've done here, if we have time. So let's see how it was available originally. So originally, the Enterprise C server looks like this. We were picking this single-use bioreactor, which is just a list of tags. And if we look at closer, there is, for example, the flow controller valve 250 002 set point %. So there's a tag, and the engineering unit is placed in the tag name. So we have to figure it out ourselves that this must be in percentages. And a lot of other variables. So what did we do with this? We used the PA-DIM model, we have a single-use bioreactor here. And now we have, for example, a flow control valve, which is following the OPC Foundation's PA-DIM model. And the PA-DIM model has device identification data, but it also adds a signal set where we have now the valve position. And the valve position can also include its own tag. First of all, there was the, the tag can be made available. And now the position of the control valve is a control signal, but it also has a set point. So this is following the OPC Foundation standard. And if we look at it from the with the OPC UA browser, we will find Enterprise C here. There's the flow control valve 01. This is now the type definition is a PA-DIM type, and that defines that there is always a signal set. There is a valve position, which is a control signal type, and that defines this, the following structure. There's a readback value, which is of type readback, and there is a set point, which is just a base analog type. So the analog type is something in OPC UA that means that it has engineering units, and it can also have an engineering unit range, such as the readback is having here. So we can also turn the, turn the unit information into standard OPC UA information. So instead of trying to guess that it's percentage, we can standardize that it's really percentage, what is the actual unit. Okay, so that ends the demo. And now I get it back to Pyry for the final conclusions.
Okay, thanks, Jouni. So let's take a look of the ProveIt questions. So first of all, what was the problem that we did identify? We had like 3 different enterprises having like very different communication protocols, like how the data was available, having totally different semantics, naming conventions, everything. And just by publishing this data to the UNS as such, the data would have been like very hard to use for basically anything. So how did we solve this problem? Was that we harmonized the data using the CESMII Smart Manufacturing Profiles and with other information models, which then enabled us to create, for example, this Grafana dashboard for the OEE data. So very, like just by copy pasting, basically like the once made template of the OEE report. So how much did it cost, or how much time it took us to do this? So we worked about 4 days. Actually, we had quite much fun doing that. So probably we would have been able to do this even faster, but we really tried to figure out all new ways to utilize the data, like how to access like all the different data sources and be creative. So probably spend a little bit more than we should have doing this. What did this cost? So if you would actually buy something like this for your factory or plant, the price range would be something like between 6,000 and 10,000 euros, a little bit depending if you need to go on site or not, and how easy it would be to deploy and get all IT provisions and such in place. This cost actually includes the license price of Prosys Forge for the first year. So the full version starts from, or the full version of the Forge actually costs $2,750 per year. Thank you for the listening, and if you want to hear or learn more about us and our company and Prosys Forge, please go to our website, prosysopc.com, or you can connect us in the LinkedIn or come and say hello to us wherever we are, or send like whatever message you figure out. Thank you.